welcome you all in today's NPTEL online certification course on mechatronics. Today we are going to talk about the microprocessors. Here if we look at this chart on the different mechatronic system components. So, basically the microprocessor falls into this category, that is under the digital control architecture. Okay. This lecture and next lecture I am going to talk about microprocessor and microcontrollers. So, as we have seen in the last class, that is on combinational and the sequential logic ICs. Okay, so if you have a simple control problem, then that can be solved using combinational and sequential logic ICs. Okay, that is integrated circuit. But if you have a complex problem, okay, where we are going to have many more number of variables to control, okay, and there is a more complex control sequence. In such type of situation, combinational and sequential logic IC word connections may not be very useful. Okay. For such complex situations, microprocessors are used and software is used to make the interconnections. Now let us look at the microprocessor system actually. So, a microprocessor system has essentially got three main parts. Okay, these are the central processing unit, which we call in short as CPU, input and output interfaces, okay, for interacting with the microprocessor, and memory. Okay. These three are the principal components of a microprocessor system. The central processing unit recognize and carry out the program instructions, okay, and this part of microprocessor system uses the microprocessor. Okay. So, in microprocessor system actually CPU is the component which uses the microprocessor, and here it carries out the program instructions. Okay. Then next is the input and output interfaces, and these handle communication between the microprocessor and the outside world. Okay. So, they receive inputs as well as they give the output. Okay. So, microprocessor receive input and gives the output through with the help of these interfaces. Okay. And the memory, as the name indicates, holds the program instructions as well as data. Okay. So, it will store the program instructions and the data, and the microprocessor having memory, input output arrangement, all on the same chip, that is what is called as the microcontrollers, and this I am going to discuss in detail in my next lecture. So, let us look at the general form of a microcontroller system, okay, or rather microprocessor system, where we have a microprocessor, or what is we call it as CPU, that is the CPU uses microprocessor. We have crystal and clock, and then as I was telling you, we have the input and output. Okay. So, we have input output unit is there. So, you have input port, output port, and these are the memories basically. Memory is there. I am going to talk about these memories little later in this lecture. Okay. And then there are different bus: address bus, data bus, and control bus actually. And what do we mean by these bus? Again I am going to discuss in the next slide. Okay. So, the buses, as I said, digital signal basically moves from one section to another along paths, and these paths we are calling as bus. Okay. Typically a bus may have 16 or 32 parallel connections, so that each can carry 1 bit. Okay. So, you can have the 16 bit or 32 bit like that. Okay. They can carry 1 bit of data word simultaneously. Okay. So, the type of bus, as we have seen here, that is the address bus, data bus and control bus. So, we have the data bus, address bus and the control bus. So, these are the types of bus which are available in a microprocessor system. Okay. So, let us look at what does these bus do basically. So, the data bus, it carries data associated with processing function of a CPU. Okay. And it is used to transport a word to and fro from CPU and memory or the input output interfaces. Okay. Each bit being carried by a separate wire in the bus, and more wire means longer is the word length. Okay. As it indicates. So, for example, for a word of length 4 bit, okay, the number of values it can have is 2 to the power 4, that is 16. Next, let us look at the address bus. Okay. So, as the name indicates, it carries signal which indicates where data is to be found. Okay. Some sort of address of the data basically. Okay. So, a computer with an 8-bit data bus has typically a 16-bit wide address bus. Okay. That is the 16 wires. The size of address bus enables say 2 to the power 16 locations to be addressed, and 2 to the power 16 indicates basically 65,536 locations and is usually written as 64K, where K is equal to 1024. Next is the control bus. It carries signal related with the control action, okay, that is operation of the input output devices. Okay. Read is used for receiving a signal, whereas write is used for sending a signal. Okay. And the control bus is also used to carry the system clock signals to synchronize all the actions of the microprocessor system. So, if we look at the microprocessor here, okay, as I was telling you, so we have address bus, data bus and the control bus. So, the 3 bus indicated by the red over here, and we have different registers here, flag register, general register. I am going to talk about what these are, instruction and instruction decoder and register. Then you have accumulator which is connected to the which communicates to ALU, that is arithmetic logic unit. Okay. So, this is the general internal architecture of a microprocessor, and from here they get external control signals. Okay. So, income and in as well as out. So, the constituent part of the microprocessor, as I said, ALU, that is arithmetic and logic units, this performs the data manipulation. Okay. So, this is the ALU which performs the data manipulation. Okay. Then there are different registers, as I said, and these are memory locations with in the microprocessor and used to store information involved in a program execution. Okay. And the control unit determines the timing and sequence of the operation. Now, let us look at the different type of registers. Okay. So, we have the accumulator register, okay, and this temporarily hold register for holding register for data to be operated on by ALU, and after operation holds the results. Then we have the status or flag register. Okay. So, as the name indicates, it carries information concerning the results of the latest process carried out in the ALU. It carries individual bits which we call as flags, and it is used to indicate whether the last operation resulted in a negative result, a 0 result, or a carry output occurs, an overflow occurs, or the program is allowed to be interrupted. Okay. So, this is all the information it has. There are common flags in the status register. For example, the flag say Z, say set 1, set that is 1, and reset that is represented by 0. So, Z, if result is 0, it is represented by 1, and if result is not 0, it is represented by 0. Similarly, you have N, result is negative, result is non-negative. Okay. C, carry is generated, here carry is not generated. Okay. And V, overflow occurs, overflow does not occurs over here, and interrupts is ignored, and interrupt is processed normally. Okay. So, this way through different flags, these are the different flags in the status register. Next is the program counter register. Okay. So, it allows the CPU to keep track of its position in the program. Okay. It contains the address of the memory location that contains the next program instruction, and the program counter is incremented each time so that the CPU executes instructions sequentially until jump or branch change the program counter out of that particular sequence. Then we have the memory address register which contains the address of data. We have instruction register which stores instructions. We have the general purpose register. These are temporary storage of data or addresses involved in that transfer between registers. And we have stack pointer register. Basically, the content of this register forms an address which defines the top of stack in the RAM. Okay. And stack is a special area of the memory in which program counter values can be stored when a subroutine part of program is being used. The number and the form of register depend on the microprocessor. Okay. For example, say Motorola 6800 microprocessor has 2 accumulator register, a status register, an index register, a stack pointer register, and a program counter register. Okay. Next slide, I am showing here Motorola 6800 architecture. So, as I said, it has got the 2 accumulators, accumulator A and B. It has index register, stack pointer, program counter are there. Okay. So, this is there, and then of course, it has output buffers, ALU, condition code register, instruction register, instruction decode and control, and here you have the various pins for the different type of addresses, clock, reset and all. Then let us look at the memory. The memory units store binary data, and size of memory determined by the number of wires in the address bus. Okay. Based on that, the size of memory is found. Memory unit consists of large number of storage cell with each cell capable of storing 0 or 1 bit. Storage cells grouped into a location with each location storing a word basically, and in order to access the stored word, each location is identified by a unique word. Okay. And size of memory is specified in terms of number of memory locations available. So, 1K is actually 2 to the power 10 or 1024. So, and 4K memory has, that is 4096 locations. Now, let us look at the forms of memories. So, first of all we will see the ROM, that is what we call it as the read only memory. Now, as the name indicates, it is a read only memory. Okay. So, it is a permanent storage of data that CPU can read, but CPU cannot write data on ROM because it is a read only memory. Okay. So, a read only memory does not require power supply to retain its data. So, it is called the non volatile memory. Okay. And this is programmed with the required content during the manufacture of the integrated circuit or the ICs. Next is the RAM, which is called random access memory. Okay. And this can be read from or written to at any time provided power is there. Okay. And data is considered volatile because it is lost when the power goes. Okay. Again, the RAM is of two type, that is the static RAM and the dynamic RAM. The static RAM retains data in a flip flop as long as memory is powered. Okay. And the dynamic RAM consists of capacitor storage of data that must be refreshed or rewritten periodically because of the charge leakage. Next is the EEPROM basically. Okay. This is erasable programmable read only memory. Which is called EEPROM. Okay. So, data stored can be erased with ultraviolet light through a transparent window at the top of the EEPROM IC. The new data can be stored in the EEPROM, on the EEPROM. Other type of EEPROM is electrically erasable, that is what we call it as EEPROM. Okay. And data in this is electrically erasable and rewritten through its data line. Now, let us look at the input output. Okay. The communication to and from the microprocessor occurs through the input output devices connected to the bus. External computer peripherals, input output devices are say keyboard, printer, displays, modems, network devices. Okay. And for mechatronic applications, analog to digital converter or digital to analog converter and say digital input output, for example digital to digital converter, provides interfaces to switches, sensors and actuators. Since the speed and characteristic of the peripheral devices differ with microprocessor, microprocessor are connected via an interface chip. Microprocessor accepts valid data from interface chip, which is indicated by the interrupt or polling. Okay. That is status bit set to 1. Now, polling is the process of repeated checking each peripheral device to see if it is ready to send or accept a new byte of data. Now, let us look at the programming of the microprocessor. Instructions executed by CPU are defined on binary code called machine code. Microprocessor can be programmed using assembly language having a mnemonic command corresponding to each instruction. Assembly language converted to machine code using the assembler, and when the set of instructions are small, microprocessor is called RISC, that is the reduced instruction set computer microprocessor. If written in high level language as say BASIC or C, compiler is to be used to generate the machine code, and these are easy to debug. So, these are the references. If you want to read further about this, then you can read either Mechatronics by Bolton or Mechatronics by Alciator and Histan. Thank you.